Pressure transmitters. A pressure transmitter is an important instrument used in an industrial system to measure pressure and send the reading to control system. In this presentation, I will explain working principle, the 4 to 20 milliamp signal, the difference between sensor, transducer and transmitters, and some common application and faults. What a pressure transmitter does. A pressure transmitter converts pressure into useful electrical signal. First, the pressure from a liquid, gas or steam enters the transmitter through the process connection. Then the sensing element inside the transmitter reacts to this pressure. This reaction may be mechanical or electrical. After that, the electronics inside the transmitter process the signal and send it to a PLC or a control system. Usually the output signal is 4 to 20 milliamps. Sensor vs transducer vs transmitter. These three words are sometimes used in the same way, but they are not exactly the same. A sensor only detects pressure, produces a raw response. A transducer converts pressure energy into electrical signal. A transmitter includes the sensing part and the electronic, and it sends a standard signal to the control system. So the transmitter is the complete industrial device used in the field. Inside the transmitter. Inside the pressure transmitter there are several important parts. The process connection allows pressure to enter the transmitter, the instrument. The process connection allows pressure to enter the instrument. The sensing element such as diaphragm moves or changes when pressure is applied. Then the signal condition circuit amplifies the filter and corrects the signal. Finally, the output stage sends the final signal, such as 4 to 20 milliamps, 0 to 10 volts, HART or field bus. The 420 milliamp current loop. Many pressure transmitters use a 4 to 20 milliamp current loop. This system is a very common industry because it is reliable, especially for long cables distance. The signal starts at 4 milliamps, not 0. This is called live zero. The benefit is that the control system can know the difference between zero pressure and broken wire. For example, 4 milliamps means the minimum pressure and 20 milliamps means the maximum pressure. Converting milliamp to engineering units. The current signal must be converted back into pressure units. For example, if the transmitter range from 0 to 10 bar, then 4 milliamps equals 0 and 20 milliamps equals 10. A signal of 12 milliamps is the middle, so it's equal 5 bar. The formula is signal minus 4 divided by 16 multiplied by span, then plus the lower range value. This scaling is usually done inside the PLC or control system. Converting milliamp to engineering units. The current signal must be converted back into pressure units. For example, if the transmitter range from 0 to 10 bar, then 4 milliamps equals 0 and 20 milliamps equals 10. A signal of 12 milliamps is the middle, so it's equal 5 bar. The formula is signal minus 4 divided by 16 multiplied by span, then plus the lower range value. This scaling is usually done inside the PLC or control system. Gauge absolute and differential pressure. There are different types of pressure measurements. Gauge pressure is measured compared to atmospheric pressure. It's common pumps, pipes and tanks. Absolute pressure is measured compared to the perfect vacuum. This is useful when atmospheric pressure changes affect the process. Differential pressure measures the difference between 2 points. It's often used for flow measurements, filter monitoring, and tank level measurements. Choosing the correct type is very important. Installation and commissioning checks. Correct installation is very important for accurate pressure measurements. Before installation, we should confirm the process, range and pressure rating. We may need an isolation valve or manifold for maintenance. Impulse lines should be checked for leaks, blockage or trapped air. Also, the wiring polarity and loop supply voltage must be verified. Finally, the transmitter should be calibrated by checking zero and span values. For safety, system must be depressurized before removing the transmitter. Applications and common faults. Pressure transmitters are used in a very industrial application. For example, they are used to measure pump discharge pressure, boiler pressure, hydraulic pressure, tank level, and filter differential pressure. There are also common faults. If there is no output, the problem may be power or wiring. If the signal is fixed at a very low or very high value, it may be an alarm condition. If the reading is noisy, the issue may be grounding or cable problems. If the response is very low, the impulse line may be blocked. Key takeaways. To conclude, a pressure transmitter is a bridge between the process and the control system. It converts pressure into sensor response, then into conditioned electrical signal, and finally into a reading in the PLC or DCS. The most important points are understanding the difference between sensors, transducers, and transmitter, knowing how the 4 to 20 milliamps signal works, selecting the correct pressure type, and installing the calibrating the transmitter correctly.